Hi, I'm Dr. Skylar L. Anderson, and I'm a professor of digital media arts and game design at the University of St. Thomas in beautiful St. Paul, Minnesota. I want to teach you how to make your own games using GameMaker from start to finish, including publishing. And in this series, I'm going to focus on fundamentals to help you learn the basics of the software so that after the series, you can continue to learn and to make the game you want to make. All right, let's learn about camera systems. So if you have a camera in your game, you can follow around your character as it explores a much bigger area than just the game window, but the game window can stay the same size. I'm first going to teach you an extremely simple camera system that anybody can implement for any game. And then I will show you a more powerful camera system that you're going to program to give you extra control and give you some cool effects that you can use in your game. So let's start with the simple camera system. Uh, in our game, this is what you're going to do. So first I'm going to just go ahead and just minimize this instance list. If you see, this is just like a list of instances in any particular layer. I'm just going to make that a little smaller. And I need to do some stuff in the room properties, but you see they're not there. Anytime you lose the room properties, don't worry, just go up here to the tab and just click it, and we get the inspector for the room, and we see the room properties. So all you have to do for this simple camera system, oh, I forgot that I needed to add my mouse highlighter. My mouse highlight, there we go. Now you can see where my mouse is. All you have to do, you click open the inspector, the properties for the room. You have a little drop-down menu called Viewports and Cameras. Click that open. You're going to check this little box that says Enable Viewports. Open up Viewport 0. Check Visible. You're going to see these white lines appear. So if I zoom out, you'll see these white lines. It's kind of much bigger than our game window. Don't worry about that. And then the width and height of camera and viewport, we're going to make these all the same. We're going to make them the size of our game window, or our original sort of game size resolution, I guess I should call it, our game resolution. So 480 by 270, 480 by 270. And then you see the white rectangle has shrunk to the size of our game, and then object following. Click that, click objects, and click O player. And what horizontal and vertical border does is when you reach the border, right now it's 32 pixels and 32 pixels. If I were to keep this that way, when my object was 32 pixels away from the border would then be pushed by my object wherever I move. But if I want it to follow my OPlayer object like precisely as it's in the center of the room, put this up again, I just make the horizontal and vertical border half of each value. So the horizontal border, the width of my resolution is 480, so I'm going to make this 240. And my vertical border, I'm going to make half of 270, which is 135. And now the camera will follow this object perfectly, like pixel perfectly. And lastly, just to test this out, because if we ran the game right now, nothing would be different. To test it, we need to make the room bigger. So scroll up here to the width and height of the room, and let's make it big, like 1020 wide and 720 tall. I chose this specifically because I think it works well with the size of my collision. So I'm going to open up my collisions layer, and I'm going to paint O block around the room so I can have a new border. Now, even with this border, we can shoot it to destroy it, right? So it doesn't matter that much, but I always like to add a border to whatever I'm working on. And I'll just leave this border here. I'm going to add some more stuff, right? Like this. Very good. Yeah, that looks pretty good. I'll delete this stuff right here. So now we have like a little level we can explore. And now if we run our game, top-down game, there. Now we have this camera following us around a much bigger room, even though we kept the resolution of our game exactly the same. Hold up. I noticed these aren't hitting. I'm telling you, the number of times I've had this issue. Watch this. You'll see that my bullets aren't rotating, so I can fix that really quick. Yep, they're the wrong orientation. That should be really easy to fix. It's because I forgot to add bullet dot image angle equals dir. I should go into my notes and add that so the next time I record this tutorial. Yeesh. There we go. There we go. I'm going to add that to my notes really quick so I do not forget to add that. There we go. To my notes. Because without that, it's going to be an error every single time I record a version of this tutorial. Because I like to update tutorials and keep going with them. Anyway, there we go. So now if I go back to bullet, I like that y'all get to see me troubleshoot some things. Now, some things I edit out when I'm troubleshooting, but I like to leave in some things that I troubleshoot to let you know that even me, like when I'm making stuff, I notice issues and I find them and I fix them immediately. I don't let them stack up. That's one thing a lot of people do is that they find a bug and they're like, I'll fix that later. No, you find a bug, you do not work on anything else until it's fixed. And if you have to roll back to an earlier version of your game, that's what you do. All right, now that we have the camera working, I can teach you how to make a better camera, a more powerful camera system that will give you a little bit more control. So for now, we're going to keep everything the same, except we're going to open our game and we're going to open up here and we're going to change object following to none. So it says no object. So it's not going to be following this anymore because we're going to manually code our camera. But everything else we've done, we're going to keep the same. You have to do this part too. So now we're going to create a new object. I always lose track of objects sometimes. Element, oh, there we go. New object, we're going to call this object OCamera. And in OCamera, we're going to add a create event. Actually, before we start coding this camera, let's make sure it gets created and added to our rooms. So how we're going to do that is that in our game and any other room in which we want the camera, we're going to go to its creation code, and we're also going to add instance create layer 00 because it doesn't matter where it gets created. We'll have it added to the instances layer because that's totally fine. OCamera. So now this camera will be added to the game. Always good to do that before you start working on an object. Add it to your room and then start working on it so that you can very quickly test it. In the create event, let's start adding some things. Let's declare some variables. Cam equals view camera, open square bracket, 0, close square bracket, semicolon. This is that viewport I was telling you about. And this just gives a name to our camera in the room. And then cam follow speed, I'm going to set it to 8. Comment lower number is faster. Follow equals O player. And I'll comment what object to follow can be changed for cutscenes, as an example. If you want the camera to move to other objects or follow other objects, that could be changed. And then width half equals camera get view cam times 0.5. You could also write divided by 2. Same thing. 0.5. And then height half equals camera get it's camera get view width. I forgot. Camera get view width. And then camera get view height of cam times 0.5. Couple more variables. X2 equals x. This is x2 is where the camera wants to go, not necessarily where it is, and then y2 equals y2 is where the camera wants to go. Now, something you need to know about how we move cameras in GameMaker is that you see this rectangle here. If I were to tell the camera to be, say, at position X40, Y40, that corner of the rectangle would be right here, 40 pixels. There we go. Or these are 30 pixels, right? So if I told it to be X30, Y30, the white rectangle would start right in this corner because the X and Y location of the camera is, say, anchored to the top left corner here. So we add this variable width half, and height half, because we're going to have to do some funky math to keep things in the center of the camera. Otherwise, what the object we're following will be always in the top left corner. Now, in the OCamera step event, we're going to write a lot of things. So let's get going. Try to follow along. Comment, update, camera. If instance exists, follow. I'm going to comment here. If there is an object assigned to follow, then x2 equals follow.x and y2 equals follow.y. Now, as we've learned in a previous part of the tutorial, by having an instance name or a name given to an instance of an object in the room, and if you add a period or a dot and then a property or a variable of that instance, you can look it up, check it, or even change it. So that's what we're doing. We're checking the X location of O player and the Y location of O player, and we're telling the camera that this is where it wants to be. But doesn't immediately mean that it goes there. It's where it wants to go. New comment, update object position. X plus equals, open parentheses, x2 minus x, close parentheses, divided by cam follow speed, semicolon, moves slower the closer it gets to the follow object. Same with y, y plus equals y2 minus y divided by cam follow speed. Same thing. And then new comment, keeps the camera from leaving room boundaries. Move my mic a little closer to me. There we go. So we're going to add a clamp here. X equals clamp X width half, comma, and then room width minus width half. So this is going to keep its horizontal position clamped between two values. And one value is going to be, it's going to be clamped on the small end, half of our camera width, which would be 240. And then for its maximum, it'll be 240 left of whatever the room width is. Now, this is the location of the camera object, not necessarily what our camera will be showing. Now, that's going to matter in a moment here in just a second. Let's do the same thing for Y, because the object of the camera object, camera, we want it to be where we're sort of following. We want it to always be the center of the frame. Y equals clamp Y height half, comma, room height minus height half. And then here we go. We're actually going to update the viewport in the of the GameMaker camera. Update camera view, camera set view POS, camera set view position. It's POS. Open parentheses. The camera or viewport that we're going to be changing is cam. It's what we assigned in the create event. And then X minus width half, Y minus height half. So it takes whatever location OCamera is currently at and then moves the viewport in the room to be half this way, half this way. So it's always going to be properly located. We want our OCamera to always be in the center of the frame, and it moves the camera, assigns the X and Y position of the camera to always be that far away. That's the best way I can explain it. But let's run the game. Maybe we should just see it in action. But now we have a more fluid camera that kind of like follows behind, and then when we stop, the camera sort of stops as well. Let's have a sudden stop so you can see the camera sort of move more gradually. Just a little bit easier, a little bit smoother. Let's also add a screen shake effect that you can implement whenever you would like. So let's go to the create event. And in the create event, we're going to declare some variables. Comment screen shake stuff. Shake length. Oops. Shake length equals 0. This is time length in frames, like how long you want the shake to occur in game frames. Shake magnitude equals 0. How big of shakes in pixels, like how much do you want it to shake in terms of distance. And then shake remain equals 0. Countdown timer for screen shake. And then buff equals 15. This is distance in pixels from edge of room. Because we're going to be having a screen shake, we're going to just add a 15 pixel buffer because that's half of what our blocks are. From the edge of the room, our camera is never going to leave or going to go further than 15 pixels away from the edge of the room. That way, if we ever have a screen shake, we can have it shake up to 15 pixels without the camera ever leaving the room. Now, in the step event, we're going to update the clamps to include the buffer. So here, where it says for the X clamp, where it says width half, you're going to add plus buff. And then over here at the end, where it says room width minus width half, you're going to add minus buff. Same over here, height half plus buff, height half minus buff. And in the step event, we're going to add a new section right before update camera view and after the clamps called screen shake. X plus equals random range. Now this is the first time we've used a function to generate random numbers. You use this all the time in designing games. Random range, you can put in 2 real numbers, meaning it may have a decimal. So like if you could put 1 to 2, and this would randomly generate a number between 1 and 2, but it could generate like 1.5 or 1.8 or 1.38 or what have you. Another useful function that I use all the time is iRandomRange. iRandomRange generates a random number, but it's an integer number. So you'd have like between 5 and 100, and it would give you a random number between 5 and 100, and it would be a whole number, a whole integer number, 5, 15, 58, 76, 100, 99, without any decimals. But for this case, we want it to just be random range because we actually want some real numbers to add us some subtlety to the shake, especially for such a small pixel art game. We will write in this, the 2 values are going to be negative shake remain and positive shake remain. Same with y plus equals random range, negative shake remain and shake remain. And then another comment, make magnitude, man, I'm not typing well, magnitude of shake get less intense over time. Shake remain equals max 0 shake remain minus open parentheses 1 divided by shake length close parentheses multiplied by shake magnitude close parentheses semicolon. Now you can walk through the math here and figure it out yourself. All I can tell you is that this works, and yes, it works. That's what I'm going to tell you. What this does is that it takes the shake remain and then makes the magnitude uh, of the shake get less intense over time. Let's now to use the screen shake, we're going to write a script that we can use anywhere in our game. We haven't used scripts yet. It's a new type of asset, so let's minimize stuff and add a new group, create group called scripts. Now, script is basically a collection of code, and you can pass information into this collection of code and alter how it behaves. Now, these scripts in the asset library are scripts that any object or anything else can call on or use anywhere in the game, but you can also have object level scripts and where basically you store a section of code as if it were a variable you can call on later. And all you have to do that is oh yeah, you write function. And then what do? Function. Oh, I'll create a new script and then I'll do it back here. Sometimes I forget. So let's create a script. This shows us the format. Here we go. Function and then the name. So this script, while I have this open, I'm going to call this screen underscore shake. There we go. And just always make sure if you're using an asset level script that the name of your script here matches the name of your function here. I'm going to delete these comments. But before we work on this script, I want to show you what an object level function looks like. It's the exact same format. It's function my cool script, open and close parentheses, open curly bracket, close curly bracket, and now I can write a bunch of code. And now I can use this script in my step event or other places, and basically it's a variable that holds a bunch of code. And you can also pass through arguments here, like this is thing1, and then comma underscore thing2. And then we can use whatever information we pass in here later. Like, so for instance, if I were to add it here, the step event. Now don't do any of this, I'm just sort of demonstrating. What is this called? My cool script with 2 arguments. I could write my cool script and then write 50 and 75 as like values that we're passing through it. And it would run this code in here with these values because we would do code that would include these 2 local variables, basically like thing like x equals thing1 plus thing2. And yeah, I think the scripts are just like, these functions are just super fun and functional and very useful. Right now we're going to create a game level or an asset level script that we can use anywhere to create a screen shake. So we are going to write with camera indent if magnitude is greater than shake remain, open and close parentheses, shake magnitude equals magnitude. I'm going to wait for this to recognize. Oh, I need to go up here and add these local variables, magnitude and frames. Give it a second and it'll turn these into local variables. Very good. Let me just adjust my headset levels. I was coming in a little hot. Shake remain equals magnitude. Shake length equals frames. And that is it for our script. Now, one thing I want to do is that I will properly indent this by highlighting it and hitting indent. And now we can call on this function anywhere in our game that we want to. Yay. Let's do that. So to test it, let's go to the create event of oBullet, right? And write screen underscore shake. And you'll see as I'm typing it out, like it pops up and it tells us what we can add to it. Screen shake. Down here too, screen shake, that tells us what the 2 arguments need to be. It's really nice. Let's say a magnitude of 2 pixels, very small, because the bullet's firing, that's a lot of firing. So we want a very small magnitude and a number of frames, just like 10 frames, 1/6 of a second. And now whenever we fire a bullet, it should give us a little subtle screen shake. Yeah, there we go. It's shaking. Now, if you want to see how this looks like when it's bigger, let's say a magnitude of 10 and a duration of 20. Yeah. Or a duration of, let's say, 120, so 2 seconds. Beautiful. So I'm going to change this back to just be 2 and 10. And now we have a subtle little shake whenever we're firing our bullets around the game. Adjusting my headset there. So I can go around here and I can fire, and it gives us this subtle little screen shake, which is a nice little piece of polish or juice to the game. Now, you know what time it is. You know what time it is. It is advanced practice time. And the advanced practice for a camera is adding a camera lead system. What is a camera lead? Well, right now we have this wonderful camera that sort of flows with our object, but you'll notice it flows behind wherever our object is going, just slightly, just a little. But if I'm going up, I want to be able to see more of what's up than behind me, because I don't care what's behind me if I'm moving up. Same with here. You want to give the camera a bit of lead time. Well, to do that, we can do some cool things. Let's go to the oPlayer create event, and we're going to declare some variables. Cam lead equals 100, which is a distance in pixels that will be in front of movement for the camera. Cam lead rate equals 0.1, which is the rate of change of moving the camera to where it needs to be. Cam x equals x, cam y equals y. And this is where we'll want the camera to be since we're leading it. And then in the step event, open up or create a new region. We'll call this region camera lead and region. And we will write some local variables here. Var cam dir equals point direction x, y, and then x plus HSP, y plus VSP. So that tells us the direction that we want the camera to move to. Var cam x target equals x. And guess what? That's length dir x time x plus length dir x cam lead multiplied by the absolute value. So sometimes you want the value of something and you want it to be a positive number no matter what. You just want to see how much, whether it's negative or not negative. And you use a function called ABS, which stands for absolute. And for that, we can add in the parentheses HSP divided by move speed, close parentheses, comma, and then the direction for this function is cam dir. Now we have to add absolute here because HSP could be negative. And we already have the direction, and we don't need the distance that we're measuring for length directs to be negative. We need it to be positive. And as long as it's going in the right direction, that's all we care about. If it's negative, it might be the opposite direction, in fact. So let's do another line. Var cam y target equals y plus length dir underscore y. Very similar. Cam lead multiplied by ABS, absolute value of VSP divided by move speed. Close parentheses, comma, then underscore cam dir. Now, why we have this is that the faster we go vertically or horizontally, the more camera lead we'll get as a percentage of our total max move speed. So if we are at our max move speed, it'll be 100%. If we're at half of our move speed, it'd be 50%. And so for cam lead is set to be 100, right? So if we're moving at half of our move speed, we are going to be leading the camera by 50 pixels. If we're at full move speed, it will be 100 pixels, and it will always be this relationship between how fast we're going and our max speed. And the direction, of course, is the direction we are headed when we move. And then finally, cam x equals lerp. Lerp is a funny name for a function. Let me explain it in a second. Lerp, open parentheses, cam x, comma, underscore cam x target, comma, cam lead rate. Same with cam y equals lerp, cam y, comma, underscore cam y target, comma, cam lead rate. What lerp does here, I'll just hover over it. It says, with this function, you can find the value that equates to the position between two other values for a given percentage, where A is the first value, B is the second value, and the third value is the amount to interpolate. So I have these two values. I have the current cam y position. I have the cam y target, misspelled there, which is where it wants to be. And then this cam lead rate is set to be 0.1 or 10%. This returns the value that is 10% of the difference between these two. And by doing this every frame, it makes it sort of approach the target smoothly at a rate of 10% per frame. Now, lastly, we have cam X and cam Y. Last thing we need to do is in O camera, make it look for cam X and cam Y. So in the step event where it says follow.x, we'll change that to follow.camx, follow.camY. And we, as you recall, follow is currently set to O player, and we'll make sure that any other object that the camera could follow, if we want that lead system to also have these variables camx and camy, so it doesn't crash the game. So now when we run the game, if we did everything correctly, we move to the right and the camera gives us some lead distance in the direction we're facing. Beautiful. Beautiful. Look at that. Nice, nice, nice. That's it. I think the next part of the tutorial, we're going to add some enemies and a health system.